Hi everyone. It's really great to see so many of you today in the room. I hope you are having a great reInvent so far. So today, we are here to talk about how AWS can help you accelerate innovation with AI-powered operations and the evolution of our services over time. My name is Mihir Patel. I'm the General Manager for AWS Observability and AI Ops Services. And this is my 10th reInvent so far. So I started my career with Amazon as an intern about 15 years back, and I had a great opportunity to learn about operations at Amazon scale over the years, from being paged in the middle of the night or during a peak event, all the way to helping build and lead many AWS services with my team over the period of years. And my teams are excited to work every day to add value for millions of AWS customers.
My name is Nikhil Deban, and I lead product for CloudWatch and AI Ops. I'm an engineer by background, and I started my career working in operation-focused roles across a diverse set of industries. Now, fun fact, my initiation into cloud monitoring began when I was tasked with building out a private cloud for an energy startup serving the complex needs of geologists, drillers, and executives working across 3 continents. My journey with AWS started 7 years ago, right here in CloudWatch. Every day I have the privilege of working with visionary customers like yourselves and our brilliant teams to push out the boundaries of what we believe is possible for cloud operations.
My name is Jared Nance, and I'm a principal engineer in CloudWatch. And I started my career working across a handful of startup and enterprise-grade organizations building domain-specific monitoring solutions across manufacturing and healthcare industries. Fun fact, I actually joined CloudWatch on the same day as Nikhil about 7 years ago. And much like him, I enjoy working closely with our teams to build capabilities that AWS customers and internal Amazon teams can use at unprecedented scale.
Thank you, Jared and Nikhil. So today I'm going to show you how AI will help you with operational challenges. But why stop there? I think AI will help you drive cars, make breakfast, and fold your laundry, right? Just kidding. I think we've all had enough of these overblown AI claims. AI is not magic, but it is a very powerful tool with some limitations. So today, we'll explore how AI can help you with your operational troubleshooting experience. And it may not make your breakfast just yet, but I promise you that the real-world applications of AI for operations are pretty promising. So let's dive into some practical capabilities that we here at AWS are building to help you simplify and streamline your operations. I'd like to start today's discussion by giving you a quick teaser of a capability that we launched at Matt's keynote this morning. So imagine this scenario. You're paged about an alarm notifying you of real end-user impact in the middle of the night. And by the time you log on, Amazon Q developer has already identified a potential root cause for the availability drop. But it gets even better. What if you could tap into years of AWS operational expertise and receive not only immediate actions to find ways to mitigate the customer impact, but also get helpful suggestions on addressing the root cause? In this scenario, you can swiftly execute an AWS managed runbook tailored to your environment and quickly restore your application back to a healthy state. I hope you're excited to learn more. So over the next hour, we'll be diving into 3 topics. First, we'll start by describing an evolution of our AI operation services at AWS. Next, we'll deep dive into the newly launched Amazon Q developer operational investigation experience. And finally, we'll provide you a brief overview of how to get started with this AI-powered capabilities to streamline your operations. So Nikhil, can you help us get going?
So thank you, Mihir. Now, AI Ops is a term that has been around for a while. And in my conversations with customers, I've realized it means different things to different people. So I think it's really important that we start this discussion by describing the expected evolution of AI Ops and be really honest about where the industry is today. So all of this started with rule-based systems. These systems are typically very precise with low error rates. For example, AWS Config and Trusted Advisor have rule-based systems that trigger automation. Then we started integrating machine learning for anomaly detection techniques. Now, machine learning models do not give us certainties. They give us probabilities. Think of them more like the weatherman than the calculator. Now, both of these techniques have been around for a while and have significant traction from customers. Now, our industry is currently in the early days of using AI for incident management. Now, this involves using an ensemble of techniques, be it rule-based, machine learning, AI, and now generative AI for dynamic incident correlation, root cause analysis, and remediation suggestions. The next phase that we expect the industry to head towards is predictive insights to help customers forecast future disruption and capacity needs. Now, some good examples would be the ability to detect like memory or disk leaks and proactively telling you about something that will go wrong in X hours if you do not take action. There is also a promise of the Holy Grail, which is fully automated systems that are self-healing. But it will be a journey and take some time if we were even to get there. Now, with this context as background, let's talk about a few challenges that face customers today when analyzing their CloudWatch data. Now, with the ever-increasing volume of data, customers find it hard to know where to start their investigation and answer the fundamental question, what changed in my application? Customers want to be proactively notified of early warning signs of potential issues before they become critical. And it's particularly challenging to predict and identify the unknown unknowns that weren't even on your radar. To illustrate this concept further, consider the metaphor of Lego blocks. Now, I am a proud parent of 2 boys, and they absolutely love their Legos. My wife and I, we try our best to make them clean up after their playtime. Unfortunately, what it means is that the next day, we start with something like this. So when my boys ask for my help finding a block of a specific color and a shape, we're basically scratching our heads. It's at moments like these, I wish I had a magic wand to quickly sort and arrange the blocks by colors. Well, and guess what? You already can do that with your CloudWatch logs. So last reInvent, we launched this capability called pattern analytics, and hundreds of thousands of customers are using it, and they have told us that it has changed the way they interact with their logs. So now, anytime you run a query, we automatically surface key patterns in your log query results. So similar to organizing the blocks by colors, this feature helps you synthesize thousands of log entries into a few critical patterns that help you kickstart your investigation. As an example, in this query, you can see that there are a few key patterns in your logs, and we also tell you how often they occur. The pattern with the word error is likely a great starting point for your investigation. So this is awesome. We now have blocks neatly organized based on a few easy-to-distinguish patterns. Now, wouldn't it be great if I was also notified if something was to change? Imagine I step out of the room for an hour, and my kids have somehow managed to acquire a net new set of blocks. Now, in an ideal world, I'd return to find those blocks neatly arranged in their own basket, as if Mary Kondo herself had paid a surprise visit. Unfortunately, my kids have completely missed the memo of the life-changing magic of tidying up. But here's the good news. While I can't Mary Kondo my kids' toys explosion, we at CloudWatch are pretty good at organizing and helping you make sense of your cloud data. This brings me to a second awesome ML-powered capability already available in CloudWatch. It's called the compare mode. Now, looking at the snapshot, I can see a new pattern emerging in my logs and how often it is occurring, which is, again, likely a great place for you to start the investigation to determine what has changed. At the bottom of the screen, you actually have this pretty neat histogram that enables you to visually compare how a specific pattern trends over 2 time periods. So as we were building out these 2 features, it got us thinking, what if we were to combine these features and make the process automatic? Imagine like a fruit sorting machine that filters out unusual items without any manual input. We thought, why not do the same with your log data? So that brings us to the third ML-powered feature available in CloudWatch, always-on logs anomaly detection. So it's really simple to get started. You literally just have to enable this capability on your log group, And after that, CloudWatch will constantly evaluate your incoming logs, compare it to historical baselines, and you will be notified of anomalous trends that point to emerging issues in your applications. Now again, looking at the snapshot, we show you the logs anomalies view with key trends, key patterns, as well as other important details for you to dive deeper, such as priority levels and the last detection time. So to summarize, we already have some pretty cool core AI Ops capabilities built into CloudWatch today. Number one, pattern mode, which helps you cluster your logs into critical patterns to aid your investigation. Number two, compare mode, that helps you answer the critical question of what changed. My application was healthy yesterday, but something is not right today. What changed? And finally, always-on anomaly detection, which automatically analyzes your incoming logs and proactively notifies you of emerging issues. Now, I've focused all of these examples on logs, but we have similar set of anomaly detection capabilities even available for other telemetry types, such as your metrics. So if you haven't checked out these AI Ops capabilities or the enhancements that we have built into them over the years, right after this session would be a great time to ping your teams or actually go check them out yourselves. So another AI Ops capability that we offer in CloudWatch is actually natural language query generation for your log and metric insights queries. So we GA'd this feature earlier this year, and it has been widely adopted by our customers. Now we know that you value our query tools for their ability to support fast, interactive drill downs into your telemetry, but we also appreciate that it takes time and domain knowledge to ramp up on our query syntax. So with this launch, we made it really easy for you to get started with our log and metric analytic capabilities. You simply ask a question in natural language, and we generate the query for you to run. In addition, we also actually provide you a line-by-line explanation of the generated query so that it helps you learn the syntax. And finally, using natural language prompts, you can easily modify the existing queries for iterative deep dives. And the cool bit about the set of capabilities that I just talked about, they're all available at no additional cost for you to use. All right, so now that we have covered core CloudWatch AI Ops capabilities that have gained popularity over the last 12 months, I'll hand it back over to Mihir to go into more detail on our motivations to go deeper in this space and tackle even harder customer problems.
Thank you, Nikhil. So let's start by quickly walking through the challenges we've heard our customers with large-scale applications and operations. They often lack the right data to help triage an issue. And even if they have the right data, it is often challenging to piece all of the signals together and make sense of it to get to the root cause. Customers are also often alarm and tool fatigued. And there is oftentimes alarms firing that may be related to each other, but it's difficult to figure out which ones are connected with other alarms. Today, customers also use many tools, and ideally, they want insights and data in a single place so that they can get to the root cause quickly. Customers also tell us that correlating different signals, including metrics, logs, traces, AWS health notifications, as well as different events such as deployments, it is challenging. And even after they get to the root cause, they want to get the best or the optimal way to fix the root cause and ideally prevent it from happening again. And who am I kidding? When you are paged at 2 a.m., it is difficult to stay calm and composed. Now, I don't know about you, but when I'm paged at 2 a.m., I'm looking more like this. And this slide just illustrates the many steps an operator has to take today to get to the root cause of an operational issue. Does this workflow look familiar? Yes. It often requires operators to take trial and error approach and sift through many different signals together to identify and then remediate the issue. So at Amazon, before we write a single line of code, we try to understand the full requirements of the product, and we call this working backwards process. So when LLM technology came to forefront about 12 to 18 months ago, we embarked on a journey to do working backwards and determine the ideal customer experience and requirements from an AI Ops experience. And this slide briefly talks about a few themes about operating applications at scale, from automatic instrumentation and data collection to detecting and prioritizing alerts, to providing a guided root cause analysis and operational troubleshooting experience, along with recommended actions and continuously learning and evolving and improving how you operate your services. And over the last year, our team has been hard at work to deliver these core requirements. And so today, I'm thrilled to announce the launch of Amazon Q Developer Operations Investigation in preview. This capability offers guided operational troubleshooting experience from issue detection to triaging through remediation. It automatically analyzes various telemetry signals, including your CloudWatch telemetry, CloudTrail logs, deployment information, changes to your resource configuration, and various AWS health events. It can automatically start investigation on your behalf in response to an alarm, or you can engage with it from AWS Q chat experience as well as 80 plus AWS consoles. It also provides you a collaborative experience to investigate in AWS console in Amazon CloudWatch. Now, a picture may be worth 1,000 words, but a live demo is worth 1,000 pictures if it works, right? So let me welcome back Jared to walk us through a live demo of this capability.
Thank you, Mihir. All right, before I get started, do we have any operators in the room? So you get paged for operational events? All right, cool. Yeah, me too. So you're in the right place. I've been on call for roughly 10 years, and I use CloudWatch every day to debug applications as I build them, to troubleshoot incidents in real time, and for exploratory data analysis, where I'm trying to learn more about the performance of our services at runtime. So I live and breathe observability every day, and I'm very passionate about improving the tools we use to make us all more efficient. I'm going to cover this demo in 3 parts. First, I'm going to give some background about a sample application and incident. Then I'm going to show you how I can use Amazon Q to troubleshoot and resolve that incident. And finally, I'll tell you how you can get started for yourself. I'm going to tell the story of this incident from the perspective of a DevOps engineer. But first, let me tell you a little bit about the service and the situation I'm responding to. In this story, I manage a service platform that enables veterinary clinics to manage their bookings, pet histories, and general capabilities that these offices need. This is a multi-tenant application, which means that my service processes requests for multiple veterinary clinics at any given time. On screen, I'm showing the clinic portal. This is the UI that my customers, the clinics, use on a daily basis. They can sign in, see a list of their customers, manage their pets, and create bookings. Booking visits is a core operation for the clinic business, and as a service provider, it's an essential operation that I need to keep available. So let's take a look behind the scenes of this service and the incident that I'm going to respond to. Whenever a customer visits the pet clinic site, their requests are going to go to an ALB, which routes the request to my front-end service running on EKS. That service will handle authentication, authorization, validation, and will route the request to a back-end microservice that's responsible for handling the specific operation required. These are all Java Spring web app services running on EKS. And each of these services has their own dependencies, whether they're storage, messaging, or other third-party services like our payment processing system. All of these services work together to deliver the user experience that I described. And remember, this is a multi-tenant service, which means that where each tenant is an individual clinic, and these services are all processing requests from multiple clinics at any time. Now, this distributed architecture is nice for a few reasons. It allows us to compartmentalize complexity, and it allows each component to deploy and scale independently. But with all of the benefits that service-oriented architectures bring, they also have additional challenges when it comes to monitoring and observability. Observability data or telemetry may be scattered, and issues in one component may affect many components, creating a lot of noise in the system, which makes it difficult to localize issues. Let's take a closer look at the data flow for when my customers book visits, and let's walk through the sequence of events that are going to lead to our incident. Whenever a customer books a visit, their request will go to our front-end service. that service is going to route requests to our visit service, which is responsible for recording the visit in a DynamoDB table. Now, today, something unusual is going to happen. One of our clinics is going to start driving a large number of requests to book visits. Maybe they have some technical issue on their side, or maybe there's an epidemic affecting a lot of animals. When that happens, my Dynamo table is going to start throttling the visit service, and it's actively limiting the requests because we've exceeded the capacity that we've assigned to the table. Specifically in this case, it's going to throttle write traffic, so read operations will continue to succeed. The back pressure is going to cause an increase in latency on my front-end service, and eventually these requests will start failing. And now, across multiple clinics, owners are struggling to schedule urgent visits for their pets in need of medical care. Imagine it's Saturday morning, and a pet owner notices that their dog isn't eating. They're trying to book an urgent visit for their pet, but the requests keep failing. The requests just hang and eventually fail. This is the real impact of our system's availability, and so owners may seek care from other providers. The clinics will lose direct revenue from specific visits that couldn't be booked. All of this impacts my business and erodes the trust that my customers have in our ability to deliver the service that they need. Maybe this situation or some version of it is familiar to you. It has common elements with issues that I've faced personally multiple times in the past. We have a distributed system where back pressure is impacting multiple components. We have a top contributor problem where the failure is being caused by a single customer or device. Needless to say, it's not a fun situation to find yourself in. So I'm going to put my operator hat on, and let's pretend that I've been paged into an alarm on my front-end service. At this point, all I know is that the book visit availability is impacted. And I understand the criticality of the operation and how important it is for me to get the service back online. So maybe I start looking at dashboards or other alarms. Maybe I start querying my logs. Maybe I have a run book. But all of this data is scattered. To really diagnose this issue, I need to understand at least 4 things. First, I need to understand that the front end is experiencing errors because of failing requests to the visit service. I also need to understand that the visit service is impacted because the Dynamo table is throttling its requests. I also need to have some understanding of how DynamoDB manages capacity, the configuration of my resource, and that it's actually throttling the requests because I'm consuming more IOPS than I've actually provisioned for the table. And finally, I need to understand that the increase in load is coming from a single clinic. All of the information I need is scattered. It's in different places, and I need to remember where to go and what tools to use. All of this can take a lot of time, and the longer it takes, the higher the pressure becomes to get my service back online. But that's okay, because I've already set up QDeveloper to automatically troubleshoot this for me. So let's see what my experience can look like instead. The screen I'm showing now is the CloudWatch alarm that's fired due to the drop in availability metric. Oh, sorry. I can go to the alarm history, and I can see that we've already created an action, that we have an action that's already created an investigation, and Amazon Q is already working on this issue. So let's go look at that investigation. What I'm showing now is the Amazon Q developer investigation experience. Here in the middle, I have a panel that shows all of the findings that have been added to the investigation. You can think of these findings as facts about the investigation that I can collect and build up evidence as I go along. I can navigate across the AWS console, collecting metrics, logs, and other observations into my investigation from more than 80 AWS service consoles. Right now, you can see there's only one finding, which is the alarm that I'm investigating. At the top, I have a status that shows me what Amazon Q is doing right now. It's actually already completed its analysis before I logged in. Now, the really fun part is here. When I click on suggestions, I get a side panel that opens up and shows me pending suggestions from Amazon Q that I can review. You can think of Amazon Q like a pair operator. that's looking at the data in parallel and suggesting things that might be interesting. When Amazon Q makes an observation, it will share it through the suggestion feed. As it makes more and more observations about the incident, it will combine these signals together to produce a hypothesis about root cause. Now, I'm going to apply a filter here to just show those intermediate observations. Here I can see that I have a few metrics. We have some SNS metrics, we have some EC2, increased write bytes on some instances. We also see that I have some failing canaries. But what's really interesting and cool about this is that instead of me hunting through dozens of dashboards, Amazon Q is doing that heavy lifting for me. As I'm trying to orient myself to the incident, I'm benefiting from the increased parallelism and automation so that I don't have to do as much hunting for the data and myself. In a single feed, I have metrics, logs, traces, and change events that might be relevant to my investigation. If I like a suggestion, I can accept it and add it to my feed. If I don't like a suggestion, I can discard it to remove it from my feed. But what if I don't know what these metrics mean? I can actually click on a tooltip for the vended metrics and ask Amazon Q inline what these metrics mean in case I don't already know what they are. This gives me explanations inline so that I don't have to go and hunt for documentation and figure out what these signals mean. The second type of suggestion is a hypothesis. So I'm going to apply a filter so we can look at that now. Here we can see that Amazon Q has produced a hypothesis that describes that the Dynamo table experienced an increase in write requests, which led to throttling and increased latency. It describes the impact that it's had on my system, impacting the visit service as well as the front-end service. It even identified the specific customer as the primary contributor to increased load, suggesting that there may also be a hot partition or a hotkey problem. It gives me next steps so that I can continue to troubleshoot as well in case there are other steps that we should be taking. Now, I'm new to this investigation, right? And so I want to see the specific evidence that led to this hypothesis. To do that, I can click on this Show Reasoning link, which will show me the specific evidence that Amazon Q selected for this hypothesis. Here we can see the throttled request coming from Dynamo. We can also see a contributor insights rule that identifies the individual customer. And actually, before I go any further, who here is familiar with contributor insights? That's okay. There's not too many people, right? But that's okay. You don't have to be. Amazon Q is able to leverage these capabilities that we have in CloudWatch without you having to be aware of them or know when to use them. So I think this is a pretty good hypothesis. So I'm going to go ahead and accept this hypothesis and add it to my investigation for posterity. Now that we've accepted the hypothesis and we've successfully diagnosed the issue, I still need to mitigate the issue. And I really need to think about what the right action is for me to take. It's not unusual for there to be multiple options for mitigation. In this case, we have several options we could consider. We could consider increasing the provision throughput for the table, which will increase my baseline costs and also allow more load to the table. I could switch to on-demand, which will enable the table to scale dynamically, but my costs will become more variable. I could enable auto-scaling, but maybe I don't want to do that in this circumstance because I don't want to spend time thinking about the right auto-scaling configuration. If I had a way to throttle the customer, I might want to do that as well. In this particular instance, I actually don't know what's driving the load. I don't know whether it's an issue on their side or whether the traffic's legitimate. So I want to get out of this situation as quickly as possible. Here, I can see that Amazon Q has already identified a few actions that I can take for this hypothesis and has recommended AWS managed runbooks for me to execute right here from this console, as well as documentation articles that can help me understand more about DynamoDB and how it manages capacity in this case. So in this example, I'm going to go ahead and increase the provision throughput on my table so that I can go ahead and mitigate this issue and limit the impact that it has on the rest of my customers. I can view the runbook, which will describe the specific steps that the runbook will take, as well as the permissions that are required to execute this runbook. When I execute this runbook, it's going to use the permissions that I have. It's not going to use other permissions or elevated permissions. So I won't be able to take any actions that I personally am not already allowed to take. So let me go ahead and fill out the parameters for this runbook. Now, I know that the read capacity is not impacted, and because I know a little bit about this incident, I know that I can increase the write capacity to 20, and now I can execute the runbook. The action for executing that runbook has now been recorded in the investigation, and it gives me a link so I can monitor its results. Now, that'll take a few minutes to roll out, and I'm not going to sit here and make you wait on it, but it'll roll out and increase the capacity on the table and take us out of alarm. Now, my next steps might be to work with our customer care team and contact this clinic that's driving the traffic so that we can address the real root cause. But finally, I can close the investigation, leave any final notes, so that the next time this alarm triggers, a new investigation will be created, and Amazon Q will start investigating that issue as well. So that was pretty cool, I think. So we responded to an alarm that was triggered by a drop in availability of one of my services APIs. We were able to immediately review suggestions from Amazon Q. Those suggestions include simple observations, as well as clear evidence-based hypotheses about the root cause that correctly identified the root cause and even identified the leading contributor. It helped me identify short-term actions that I could take to mitigate the issue, and now we've recovered without having to run a single query or hunt for data. In addition to using the AWS console, many of our customers use tools like Slack. Internally at Amazon, and the teams that I work on specifically, we use Slack for most of our communications. And so we thought it would be really cool if Amazon Q could also participate in those ops channels. So let me show you what that looks like. Here, I'm showing the Slack channel for my operations team. And you can see that, and I've configured Amazon Q to connect with Slack and participate in the ops channel. The first message from Q here shows the opening of the book visit availability investigation, which starts a thread, and I can actually see that metric right here inside of my Slack that shows the signal that I'm investigating. The second message here is similar to the suggestion feed that we have. All of the suggestions that Amazon Q will post, you can find in this feed directly here in your Slack. And finally, there will also be a thread that contains the hypotheses for root cause that I can see here without having to log into the AWS console. So we responded to an alarm that was triggered by a drop in availability of one of my services APIs, and we were able to immediately review suggestions from Amazon Q and resolve the incident. So now I'd like to move on to the final part of the session. What do you need to do to get started yourself? There are two categories of things that you'll need to do to start using Amazon Q investigations. The essentials require creating an investigation group. You can think of this group as a container for your investigations that you can hang common configuration on, such as the permissions that Amazon Q will use when it accesses your resources and your telemetry, as well as your encryption configuration and retention, and third-party integrations like Slack. Now, once you've done this, you can actually start using a sample investigation or start experimenting with retroactively investigating issues that you may have already had in the past. The second category is what I'm calling best practices. These are the things that you can do to maximize the value and the performance of Amazon Q when it's investigating your operational incidents. In order for Amazon Q to properly analyze your environment, it needs to understand the relationships between your workloads, their dependencies, and the telemetry that they emit. in order to build the most accurate view of your environment, we recommend that you enable application signals, AWS X-Ray, and upgrade your CloudWatch or FluentBit agents so that you can take advantage of the latest capabilities. If you haven't done this, we will attempt to infer those connections. This inference will have some probabilistic error rate. We encourage you to enable CloudTrail logs, and many of our customers are already sending CloudTrail logs to CloudWatch. This will enable Amazon Q to use CloudTrail to detect changes in your resource configuration, which may have triggered the incident. Finally, like I showed, you can configure your alarms to create investigations automatically. It's not unusual for a single component to have multiple alarms for different functions. But like your ticketing systems, you probably don't want to create an investigation for each of these alarms, which may all fire due to correlated issues. If this is something you want to avoid, our recommendation is to create a composite alarm that you hook the investigation action to. All right, so this looks exciting, right? So how can you start creating investigations yourself? Amazon Q Operational Investigations has many different entry points from wherever you are. The example I walked you through just now was an auto-triggered investigation that was set up proactively as an action on your CloudWatch alarm. You can also ask Q Chat a question like, why did I get paged? And you'll be guided on next steps. Finally, what if I want to start an investigation from a spike on a dashboard? You can also initiate an investigation from any embedded telemetry across more than 80 AWS service consoles, which I'd like to show you now. All right, so here I'm showing a sample dashboard for my front-end service. I'm going to stick with the book visit availability issue with a slight modification. So here I can see that there's a drop in availability that looks a little bit different from the other ones. And I want to investigate that. I can zoom in to the area that I'm interested in investigating. I can click this tooltip, select investigate, and start a new investigation. I can give the investigation a title. And I can go ahead and start that. Now, this analysis will take a few minutes, and I'm not going to sit here and make you wait on it. I'm going to go ahead and show you one that I've already run. So in this case, I've modified our incident so that instead of the issue being caused by increased load, the issue's actually been caused by a change that someone made to our Dynamo table. It was me, actually. I went and changed a resource policy on the table that started denying all of the traffic. So that's probably not a great idea. Maybe we need to implement some better change management policies. But it happens, right? So let's go see the suggestions that Amazon Q has given us. Here we can see that Amazon Q has identified that there were authorization errors when attempting to perform put item operations on the visit registrations table, which impacted our visit service and our front-end service. Now, here's a really cool piece I want to show you. So when I click show reasoning, I can see the logs that show that the user was denied access. I can also see the CloudTrail change event that was captured and recorded the event. I can click on that link, and I can go view the CloudTrail event myself, and I can go see what specific change was made. Here I can see the policy that denied all of the traffic, and I can also see that who actually made the change and figure out what we need to do to prevent this from happening again. All right, so in this case, I showed you how Amazon Q can be activated from any of the embedded dashboards in any of the AWS service consoles. I also showed you how it uses CloudTrail to identify root causes when the issues are triggered by changes in your resource configuration. Sorry. All right, so let me switch back over here. So like I mentioned, you can engage Amazon Q from alarms, from Q Chat, and from any of the embedded dashboards on the AWS service consoles. With this new Q capability on your side, I hope it makes your next on-call period a little bit easier. And with this, I'll hand back over to Nikhil to help summarize the key takeaways from today's session.
Awesome. So thank you, Jared, for that very engaging demo. So as we wrap up, let's distill the essence of our journey into a few key takeaways. First, we discussed the evolution of AI Ops and how the industry is transitioning from pure rule-based and ML-based integrations to using an ensemble of techniques for incident management and root cause remediation. AI Ops is truly a journey, and we are making progress step by step. We also briefly discussed CloudWatch capabilities such as log patterns and anomaly detection, as well as natural language query generation that we launched in the last 12 months to streamline how you interact with your data. Next, we dived into the exciting new feature that we launched today in Matt Garman's keynote that helps you accelerate your operational investigations across your AWS environment. With a deep understanding of your AWS cloud environment and resources, Amazon Q Developer now looks for anomalies in your environment, surfaces related signals for you to explore, identifies potential root causes, as well as suggests next steps to help you remediate your issues faster. Finally, we walked you through a few required steps to get started with this experience that involved creating an investigation group and configuring permissions for your Q Developer, while also suggesting best practices to adopt in order to maximize the quality of suggestions from this new capability. Some of those included using application signals, X-ray, using the latest agents. Again, none of these are prerequisites, but it makes your experience better. Now, the best part of all of this is that all of these capabilities that we have mentioned today, including this latest one of operational investigations, are available to you today at no additional cost. Just let that sink in. Previously, when you used to do all of these things, you would often be creating new dashboards, you would be creating new alarms, you would be scanning a lot of data across your metrics and logs. You no longer have to pay for that because our investigation capability does that and helps you. We truly believe that using AI Ops can help you streamline your operations by surfacing these inherent connections across your data, something that today requires both domain expertise as well as experimenting with trial and error techniques. We firmly believe that this AI-assisted but human-led experience is an incredibly powerful tool when used responsibly, and are excited both for what it can do today and what the future holds as we continue our investments in this space. So we really hope you enjoyed today's session and that you will give this capability a try soon. Please reach out to any of us as we can help you get started. And last but not the least, we would really, really appreciate if you could take a moment to fill out the session survey in your mobile app. Your feedback is really important to us, and it helps us tailor our future sessions to align with what matters most to you. So thank you all so much. I'll invite Mihir and Jared back on stage, and we just want to thank you again for being here, and we will walk off stage. We'll be available here for the next 15 odd minutes in case you have any questions about these capabilities or CloudWatch in general. Thank you so much.